Now, up to this point in the course, whenever we worked with data, it was basically some dummy data which we managed in our Python code, in some variables there. And that's of course not very realistic, because by managing it there, we have a couple of disadvantages. For example, whenever we would restart the Python application, so our Django web server, whenever we would restart that, any changes to the data would be lost, because whenever we only operate on variables, the data is only stored in memory, and that data will then be cleared and lost whenever the application is reset, because it's, for example, restarted. So it's not persistent storage if we only work with variables. In addition, of course, we always shared the same data across all requests and therefore also possibly across all users. And we didn't have any rich data query functionalities. We had standard Python variables and had to write standard Python code to filter the data, to limit the data, to do things like this. Now, that's not too realistic. Whilst, of course, you always will have some data which is managed as a variable because it is just temporary data, you also will almost always need some data that should persist forever or that should be stored more permanently. So that should be stored in a database in the end. And therefore, in this course section, we're going to have a look at how we can manage data in a Django application that is more permanent, that persists for a longer time span than until the next application restart. And we're going to take a look at how we can interact with databases and how a Django concept called models will help us with that. And for this, we're going to first of all have a look at what exactly is data and which different kinds of data we can identify. And we're also going to, of course, take a brief look at what exactly a database is and which options we got there. And we're then going to explore the SQL syntax, which we can use for querying some databases. And we're going to learn how models, a concept built into Django, help us with that. And we're then going to take a closer look at the data and database specific syntax and features Django offers to us when it comes to working with models and constructing database queries to insert and update and delete and get data. So there's a lot to cover. Let's not lose any time. Let's dive right in. Now, before we write any code and explore any special Django features, let's dive into one simple yet important question. What is data? Now, of course, data in the end is, all the values we're working with in our application. For example, that could be the monthly challenges we have, that could be the products we have in a store, or the blog posts we have in a blog. That would be data. If a user inserts something in a field, like for example his or her email address, that would also be data. So that's what data is. It's the values we work with in our application. But we can actually differentiate between different kinds of data. For example, there is temporary data, semi-persistent data, and persistent data. These are not official classifications, these are just some different categories I came up with here, and I'm going to explain which kind of data goes into which category in just a second. And let's therefore maybe start with temporary data. What is temporary data? Well, that would, for example, be the user input in some form, or maybe a selected blog post which we selected by entering a specific URL. This is data which we need to work with. We want to process that input, we want to process that selected blog post and fetch the appropriate blog post from a database, for example, and show it to the user with help of a template. But this data is temporary because it's not important in the future. What the user entered into a form might be saved in a database and become persistent, but that's then in the context of a bigger entry which we write to the database. Just reading the user input values from a form, field by field, is temporary data which we only need in that moment where we process the form. So that data is used immediately and then lost thereafter. And of course, we often have such temporary data in applications that we might be building. And such temporary data is then just stored in memory, so in variables. We extract some data, store it in a variable inside of a method or a function, do something with it throughout that function, and then once we're done with the function execution, the variable is no longer referenced, it's no longer used anywhere else in the application, and hence it's automatically cleared after some time. So that would be temporary data. And this kind of data is important, and that's actually the kind of data we worked with thus far in the course, because we only worked with variables up to this point. Now, the problem is that not everything should be temporary data. For example, we might have some data which I like to call semi-persistent data. An example would be the user authentication status. If a user logged in, we might want to save the fact that the user is logged in. We want to save that somewhere, but of course a user may log out in the future, in which case this data is not needed anymore, or we might want to automatically log out a user after a couple of minutes or hours. Think of online banking where you are logged out after 15 minutes or so. So that is data which is kind of persistent, which we don't just need once and instantly, but which we might need in the future as well, but where it is okay if it's lost, or where we even might want to clear it deliberately after a certain time span, because it can be recreated, for example, if a user logs back in. This kind of data could be stored in the browser or in some temporary files. So in a place where the storage might be cleared, for example, the browser might clear its in-browser storage if it needs to free up space or for security reasons after a certain time span, but it's not cleared instantly after the data was used or after we're done with a specific task. So we have certain storage mechanisms like cookies, or in the browser, the local storage, which we can access through JavaScript, or temporary files, which we might write to the server, which are there and which persist, but which ultimately might be cleared by us or automatically. And that's this semi-persistent kind of data I like to talk about. But of course, in most websites we're building, we also have real persistent data. So data which must not be lost and which should never be cleared unless we explicitly want to delete some kind of data. And an example here would be blog posts, orders, products, users, you name it. There's a long list of data which makes up the heart of our website, which our website might be all about. For example, an online shop is all about products and orders in the end. And this data, of course, must not be lost. It should be stored forever. It must not be lost unless we explicitly want to delete one item. Now, for example, if we cancel an order, we might want to delete that order from wherever it's stored, but it shouldn't be auto-deleted randomly or anything like that. So we have such persistent data which is super important and which must not be cleared. And this kind of data should typically be stored in a database. In the end, that's the same as storing it in a file, you could say, but of course databases then provide us a more convenient way of inserting and deleting and querying data, and they give us certain optimizations to retrieve data in a faster way, and so on. And therefore, these are the three categories of data I like to think about, and of course we need to be able to work with all three of them. Now we're going to take a look at semi-persistent data later in the course, once we dive into sessions. We already had a look at temporary data. We used it throughout this course thus far. And now in this module, I want to focus on persistent data. I want to focus on storing data in a database and getting data from there and updating data there and deleting it, because that is a crucial thing you will need to do in basically any website, and hence, of course, you should know how to do it with Django. So let's talk about databases now that we know what data is and which kinds of data we have. We're going to use a database in this course section, but before we use it, it's important to understand that there are two main philosophies, you could say, two main approaches for databases out there. There are more than two in reality, but there are two big and important ones. And that are SQL or SQL databases and NoSQL or NoSQL databases. And these are two fundamentally different philosophies on how they approach storing data, which we have here. And we can use either of the two philosophies. There then exist concrete implementations of these philosophies. I'll name a few in a second. And we can choose which one best fits our website needs. Now let me start with explaining what SQL databases are all about. The main thing about SQL databases is that they store data in tables. The NoSQL databases, on the other hand, store data as documents in collections. Now, this might not tell you much, so let's take a closer look. In a SQL database, data would be stored like this. We have a table with 3 columns, for example. The column names are ID, name, and age. And then data entries are stored as rows in those tables. So the first entry would have an ID of 1, a name of Max, and an age of 31. The second entry here would have an ID of 2, a name of Manu, and an age of 32. And in SQL databases, we can also connect multiple tables through relations. We're also going to take a look at that later in the course. And we can then query these tables by, for example, saying, give me the values of the column name, so Max and Manu, for all entries where the age is greater or equal than 32. And this would then, in this case, exactly return Manu, because it gets the value from the column name for all the entries where the age is greater than or equal to 32, which is only the case for the second entry. But we're going to take a closer look at these queries and how to work with data throughout this section. Now, in NoSQL databases, we have this document-based approach, and that basically means that we don't have rows or columns, but instead we have a list of documents, which looks something like this. It looks a bit like dictionaries, you could say. It's not written in Python, it's not Python exclusive or specific, but it looks like dictionaries, except for that the key names are not between quotes. But in the end, we have a long list of self-contained documents. We don't have a clear schema for the entire table. Even though both documents have the same fields here in this example, they don't need to have the same fields. We could have 2 documents with totally different fields in the same collection. Whereas with SQL, that's not really the thing. There, all entries in the same table have the same schema, so they have the same columns which they fill. That's not the case for documents in NoSQL. We have more flexibility there. And then we have just a long list of these documents which we can query. Now, SQL and NoSQL are just the philosophies, as I said, the different ways of storing data. And we then have concrete engines, concrete products that implement these philosophies. In the case of SQL, for example, the most popular SQL database engines are MySQL, PostgreSQL, SQLite. We also would have Oracle SQL or Microsoft SQL. And we then can install these database engines on a server, for example, spin up a database server, and then run queries against that database. And that's also something we're going to do in this course. We're going to run queries against SQL databases. Now, in the case of NoSQL, popular implementations, popular products would be MongoDB or CassandraDB. Now, these are then databases which we can also set up and install or use cloud-based services to, well, interact with them, run queries, store our documents, query our documents, and so on. Now, that's SQL and NoSQL, and you might be wondering which one is better? Which one should you use? And the simple answer is, for many websites, it won't matter too much, and it comes down to personal preferences. But of course, there are some real differences as well. Depending on how exactly you're going to use your data, how your data will be structured, if you need that flexibility of not having the same schema for all entries or not, you might lean towards a NoSQL or a SQL implementation. And I have a detailed comparison video and article which you'll find attached to this lecture if you want to learn more. But to be very honest, as I said, for many websites, it won't really matter too much. And Django has great support for SQL built in. Therefore, we're going to use SQL in this course. It's the most common database you use with most SQL websites, and therefore, of course, it's the approach I want to teach you. You can also use Django with NoSQL, but you will need to install extra packages for that, whereas a rich and great SQL support is built in. And in this course, we're therefore going to use SQL. Specifically, we're going to use SQLite because that's particularly easy to get started with. And therefore, let's now understand how exactly we would work with such a SQL database and how we would run queries there. So SQL it is for this course, but what does this mean for us? It first of all means that we need to create a SQL database. And the great thing here is that with Django, if you create a new project, like here that blog project we worked on a couple of minutes ago, you typically automatically get a DB SQLite free file created. And that already is a SQLite database file, which is pre-created for you without you installing anything special. So you don't need to install any extra tools or any extra servers or software or anything like that. This is a database which basically can be created on any system. And Django should have created such a file automatically for you. If it didn't, you can create a new file and simply name it DB SQLite free. Now, I'll not do it here because I have that file already, but you can simply create such a new file if you don't have one created automatically. Now, that is SQLite free. Other implementations like MySQL need to be installed first. The reason for that is that SQLite is a very simple SQL implementation which simply works on a single file. That's great for development and also for many websites which don't have that much traffic. But if you're building a website which has more traffic and which might need to run more queries against the database, you might need better performance than you have when you're just working on one file. And then you might need to set up a dedicated database server, which simply offers better performance and so on. And that's where a solution like MySQL could come in handy. And that's why you also need to install it, because it's not just a single file against which you write queries, but instead this is now a full database server which you set up, which simply gives you better performance and so on. Now, for development, and as I said, also for many live production-ready websites, we don't need that though, because SQLite doesn't have too bad performance either. And you can visit the SQLite homepage to learn more about it. And there you will also find the When to Use SQLite article, where you can learn more about when to use it and when you should think about switching to a different database implementation. So that might be interesting as well. So we need to install a database, or in the case of SQLite, create that file. And then we can run SQL queries against that database by using certain tools. More on that in a second. For example, we can then create tables and set the table schema, so the structure of that table, with a command like this. That's how the SQL syntax looks like. And this is a command we could run initially when we're getting started with our website to set up the database structure. To add a new table named books in this case, which has 3 columns, an ID, a title, and a rating column, where we then also assign certain value types and settings to those columns. Because that's important, when you're working with SQL, you don't just have rows and columns, but instead you also define which values should be stored in the different columns. So you really define a rich schema describing the kind of data that should be stored in a table. And you do this once when you initialize your database. So that's a command you could run to create a new table with those fields, with those values and settings. For the ID field, you see that besides the value integer, we also have primary key and auto increment settings, which basically just means that this field should be auto-populated whenever new data is entered in that table, and that it should be an auto-incrementing ID, which is also unique in the end. And we're going to take a closer look at the different fields we can set up throughout this section. This here is just a rough overview. So that's a SQL command we might need to run initially when we set up the database. Then, once it is set up as part of our website or application we're building, we might need to insert data into the table, so into the database. And in SQL, that insert command typically looks something like this. Insert into, then the table name, then pointing at the columns where we want to insert data, and then the values for those columns. In this case, Lord of the Rings as a string, so as a text, because that's the type we set for the title column. And then 5 as a value for the rating, 5 as an integer value, because that's the value we set there. I'm not setting the ID because of auto increment primary key. That will be auto populated, and it's an auto incrementing number. And of course, then at some point in our website, we also might need to get data from a table, maybe also with a certain condition set. And then that's how the SQL syntax would look like. Select star from books simply means select all columns, so all values from the books table, and then where rating greater 5 means for the rows, so for the entries where the rating column has a value greater than 5. So these are some example SQL queries. And if that's a bit fast, there is a reason for that. Because we are not going to write those queries when using Django. Because Django thankfully has a built-in feature called Models, which allows us to work on data on a higher level, so that we don't have to write those low-level SQL queries and commands, but that we instead can describe what we want to do with our data. For example, that we want to save data or delete data, and then Django will automatically create those queries under the hood and execute them for us on our behalf. And that's very convenient because that means that we don't need to learn a new language, this SQL query language here, but that instead we'll be able to focus on Python and working with Python data. So let's take a look at this models feature then. As explained, Django has this feature called Models, which allows us to write Python code and work with Python classes, as you will see, and Django will under the hood then construct these SQL queries. Therefore, we can focus on our data and our business logic and not on writing those low-level queries, and we therefore also don't have to learn SQL as a new language, which we of course don't really want to do here. Instead, with models, the idea is simple. We'll just define data models, which basically means that we'll create classes in Python, and then we use those classes or objects based on those model classes to run common operations. And Django will then create the SQL queries for us. Now that's very abstract, and therefore, finally, after all that theory, let's dive back into some code and let's create and use some models. That doesn't sound like a bad idea, I guess. So to dive into some code, I created a new Django project. I named it Bookstore because I'll play around with some book data. So like if we had a store where we are selling books. But that's of course totally up to you. You can simply create a new Django project with the Django admin command. And in there I changed nothing except for my VS Code settings which I added, which are the same settings I've been using in the previous course sections. Now the idea here is that we now get started with Django models and therefore with working with a database. And hence for this, I will now first of all open up that integrated terminal again and then create my first app here. With the manage.py file, I'll start an app and I'll simply name it Book Outlet. But the name is up to you. That's simply the part of the overall project where we're dealing with our books and with selling books and so on. Now here I don't have that SQLite file yet, so I will simply create it manually and create a db.sqlite3 file in here just like this. And in there I won't do anything, I just store it like this. Now in the book outlet folder, so in this app folder which I created, there we have this models py file. And this is now the file which will become important for us when it comes to creating those Django models. So those classes, as I already said, which we'll then use to interact with the database and to store data there. The idea is that in this models py file, we define our data entities. So blueprints for the data objects we're going to work with in this application. And here in this book outlet part, we're certainly dealing with some books, which we're selling, for example. Hence, in here in this models py file, I'll add a class named book. The name is up to you, but of course it should describe the kind of data you want to represent by this model. And then this book class should extend another class. It should inherit from another class. And in Python, we do that by adding parentheses after the class name. And it should extend the models.model class, which is a built-in class provided by Django. And this models import, which we need for that, should already be there. If it's not, simply add it manually. And then we add a colon and can now work on the class definition. So in here, in this class, we now want to define the structure of a single book. Keep in mind that SQL databases are table-based, so now in the end, we'll define the structure of a book table. We're going to define how our book entries should look like, which fields they should have. So for example here, we could say that every book has a title. Hence, we add a title field, a title attribute here to this class. And we now, and that's important, we now want to assign a value here. And the value now is not a title like Harry Potter. That's not what we want to add here, because our class should just be the blueprint for book instances, which we then create thereafter. And it would be the concrete instance, which, for example, has a title of Harry Potter. Instead, the value we define here in the class is simply an indicator for Django that tells Django which kind of data we later want to store in a title. And here we know that we want to store some text in there. That title should be some text. And to be very precise, we need to tell Django which kind of text field it should create in the database. And you can Google for Django model field reference to find an article from the official docs where you have a list of all the officially supported built-in field types you can set. You can also build custom types, but that's beyond the scope here. But if you scroll down on the right here to field types, then you have a list of field types you can set. And for example, for the title, I want to set a char field type. You see that here? A char field is a string field for small to large sized strings. So what I want to do here is I now want to set this to models.char field. And that's important. You get those value types which you can assign from the models module, which we're importing from Django DB. That then exposes a couple of classes in the end, which we instantiate, like the char field class. And behind the scenes, that tells Django that when later a book is created and stored in the database, that book will have a text value type. And then because it's the char field constructor, the char field class which we're using here, Django also knows a couple of other things. For example, that it won't be a super large text, so not like the content of a book, which would be a very long text, but that it's a, well, small text or a reasonably large text, but definitely not a text that spans multiple book pages, for example. And that is because we use the char field class here. Now, to char field, we actually should add one argument when we call the constructor as we're doing it here, and that's the named max length argument, which we should pass here. You can pass arguments to these field type classes when you construct them, and there are a couple of optional arguments. We'll have a look at some of them later, but some fields also have necessary arguments which you need to provide. And max length here actually is required. As you see here in the official docs, char field has one extra required argument, and that's the max length argument. And there you simply define the maximum length of text that may be stored here in the database later for this field. And we could say that a title shouldn't be longer than, let's say, 50 characters. Of course, this value is up to you. Now with that, we'll tell Django that it has to check the title of a book later when we insert a book into the database and deny the insertion if the title would be too long. Now we can also add another field, and let's say we also want to add a rating here to our book. For that, I'll add a rating attribute. Again, these attribute names are up to you. You just have to ensure that you don't use reserved names like, for example, pass, which is a keyword in Python. But other than that, it's up to you. And here, I don't want to set this to a char field, but instead to a number. And to be precise, I want to set it to a number without any decimal places. So I'll set this to an integer field. Now here you see in this little box, which my IDE gives me, which arguments we could pass in here. But these are all optional arguments, because if we have a look at the integer field documentation, if we go there, that this does not have any required parameters which you need to pass, and no required arguments. You can pass in certain options, but you don't have to. And now with that, we would define that we want to have a book data entity in our application, in our website, where every book that we create later has a title and has a rating. And Django will then go ahead and create a database table called books. It takes your class name, converts it to all lowercase and pluralizes it. And in that books table, it will then automatically set up a title column, which accepts text with a max length of 50, and a rating column, which wants integer numbers. And that's also important, it will automatically create an ID column, which has an auto-incrementing number. You could explicitly set this here by using Models auto field, but you don't have to. This is added to every data entity automatically by Django. And this auto-incrementing ID field is very helpful because that gives you a unique identifier for every data entry. Because of course, at the moment, we could use the same title on multiple books, so that would not be unique. Hence, having such a clearly unique field is definitely something which can be helpful for identifying entries. But enough of that. At the moment, we only have our class. We have nothing in the database yet. So how can we make sure that we now actually do set up the database, that this table gets created, and how can we then insert data and so on? With this class defined, the first step to make Django aware of it and to get Django to work on the database and set up that table and so on is that we need to register the app in which we registered this model. Because it's a bit like with templates. Out of the box, Django doesn't know that you have this app and that you have this model. So out of the box, it's not doing anything. Instead, we need to go to our project settings, and there in installed apps, we need to add the book outlet. That was my app name, which I picked. We need to add this entry here to make Django aware of our app, and then Django will also automatically pick up those models in there. But that alone is still not enough. Now we need to tell Django that it should reach out to the database. So in this case, to this database file, which it supports out of the box. Django supports SQLite out of the box. That it should go to this file, and that in there, it should create such a table. It should create that data table for the books. And we do tell Django to do this with a concept called migrations. And you might have noticed this migrations folder before already, though it is empty out of the box if we leave that init py file aside. Migrations are a feature which basically defines steps for Django to execute, steps that will touch the database and manipulate it. For example, by creating new tables or updating existing tables. And therefore, whenever we work on our models, when we add models or update our models in the models py file, we need to make sure that we create migrations for Django to execute, so that we create those instructions for Django on how to update the database, and that we then also run those migrations. We have these two steps, creating the migrations and running them, which we always need to perform when we worked on our models. And to do that, we open up our terminal here, navigate it into the project folder, not into the app folder, but in the overall project folder. And in there, we'll again use the manage py file. And the first command which we need to execute there is make migrations. If we run that, it goes ahead and now it populates the migrations folders of all the apps where migrations are needed. In this case, of the book outlet app. And you see in there that it added this 0001 initial py file. In there, we have some Python code, which was auto-generated by Django, which now describes the operations Django should perform against the database. It didn't perform those operations yet, but it's about to perform them. We could manipulate the code in here, but for that you should really know what you're doing, and typically you don't want to manipulate it. Instead, you want to work on your models and then make migrations whenever you change them to let Django create new migration files for you. Now, if we have a look at this initial py migration file, then we can see that in the end, a migration is just a class extending the migration class, which comes from Django. That then it has this initial flag telling Django that this indeed is the first migration to be executed ever in this application. Dependencies of which we have none here, and then the operations that should be performed. And in the end, this is one of the built-in operations Django offers that will go ahead and create a table, and the table will then automatically be named books, as I said. That's the auto-naming Django will basically do here for us. And it will then create three fields in that database table, title and rating, with the char field and the integer field. And, as I mentioned, the ID, which it automatically creates for you. And primary key simply means that this will then also be optimized behind the scenes so that it's a bit more efficient to query it, and that uniqueness is enforced. So that this field, even if we would want to override it, can't assume a value of an already existing record. Now with that, we created the migrations, or in this case, the single migration. As I said, nothing was done yet though. Nothing was written to the database. To do that, we need to run another command here in the terminal. We need to run with manage py migrate. And that will now tell Django to have a look at all files in migrations folders in all apps and run all migrations that haven't been executed yet. So in this case, this initial py migration hasn't been executed yet. So if I run this command, you see Django now executed a couple of things. It actually did more than just our initial migration. You see that was also applied, but you see that also a couple of other migrations were applied. And that simply happened because this was the first time I ran the migrate command. And you must not forget that in our Django app, we have more installed apps. We have a couple of built-in apps which are also installed for working with sessions and for authentication. And some of these apps also require database tables to work correctly. We haven't really used them thus far, which is why we had no problems up to this point. But they will need some tables to work correctly in the future. And therefore, when we migrate for the first time, all those built-in migrations of those built-in apps, which we don't see in our project folder, but which exist, also were executed. Now, our migration, as I mentioned, also was executed, and therefore now our table, our database was updated. Now, we don't see that here because this file type is not supported out of the box by Visual Studio Code, because it's basically encoded in a way that can't be read like this. It's not a regular text file, but this SQLite free file will now contain the database setup which was created based on all those migrations. And with that, with those steps taken, we can now in the next lecture get started with working with that database and with those tables. And we can start with inserting some data. We created our migrations and we executed them. Now we want to work with the data. And of course, we're later going to do that in our views.py file and in our Python code. We're going to reach out to the database from in there, and we're going to insert data, get data, filter data, and we're going to do all of that from inside our regular Python files, just as we did it in the prior course sections. But to get started with working with the database, I don't want to build an entire website around it just yet. We're going to do it later though. But instead, I just want to play around with the database. And for this, we can use the terminal. In there, navigated in our project folder, we can run Python free manage.py shell. And this will give us an interactive shell, the interactive Python interpreter, to work with this Django project and to then also work with the database that belongs to it. So if you hit enter, you enter this interactive mode here. And there we can then, for example, import from book outlet, so from our app folder, .models, we can import book. Now I imported the book class into this interactive shell here so that we can interact with it. And we can then, for example, create a new book, for example, Harry Potter, by simply instantiating book like this. This is standard Python code here. We're just instantiating a class, the book model class, which we defined up there. And this class actually has two fields, the title char field and the rating integer field. And Django basically sets everything up such that when you then instantiate one of your model classes, you pass values for those fields as keyword arguments to the constructor function. So here we now add a title keyword argument and set this to a string because it's a char field. For example, Harry Potter 1. The Philosopher's Stone. And then I add a second keyword argument, separated by a comma therefore, which is the rating, which I, for example, set to 5. If I now hit enter, this is created, but the database is not touched yet. This alone won't do anything. This just creates an object in Python and stores it in a variable. This does not yet do anything with the database. But instead, this is now an object which has more than just 2 attributes. Keep in mind, our class only has 2 attributes and nothing else. There's nothing in there, no custom methods, nothing like this. But because we inherit from the model class, which is built into Django, our objects which we create based on our model do have some built-in methods. And for example, there is a built-in save method. Every model class which we build, which extends the Django model class, which it should, will have a save method. And when you call save, that data object will in the end be written to the database. And that of course means that now behind the scenes, once we execute the save method, Django will construct a SQL query which looks something like this, and it will execute it for us. So we never have to write that query, but Django will do it for us, behind the scenes. So here I can now hit enter, and now this was saved to the database. And of course, we can also save another entry, Lord of the Rings. Here we could create a new book and set the title to Lord of the Rings and set the rating to, let's say, 4. Hit enter, and then use Lord of the Rings and call save, like this. Hit enter, and now this was saved to the database as well. And of course, you can add more entries. But before we add more entries, let's find out how we could get those entries to really see that something was saved. To see our changes to the database, to see the data that was saved, we can query the database to get data. And that's, of course, also a common task. You very often, of course, want to not just save data, but you also want to fetch data to then display it on a page, or in this case, to see it in a console. And to get data, we also can leverage this model feature Django gives us. For saving, we instantiated the class and called save on the instance. For fetching data, for getting data, we use the class name itself, so with a uppercase B at the beginning, my class name here. And on that class, there is a static attribute, a static field, which we can now access, and that's the objects field. Now, we didn't define that, but again, it exists because we inherit from the model class. So that objects field is a field added by Django. And that is now a field which, again, actually points at an object with a lot of built-in methods defined by Django. For example, there is an all method. This all method will get us all the data, all the books stored in the database. So if I hit enter, I get back a so-called query set, and you see that in the end, this is a list with 2 items. Now, it's a bit cryptic what we see here, but we see that there are 2 items in there, which kind of makes sense because I did save 2 books before. Now, maybe we would like to see something more useful down there, and for that we can actually go back to our class and change something there. So let's do that next. When we're working with our models, we can always go back in there and change them. We can change the fields it takes, we can add new fields, but we can also add methods. And we can add methods that hold certain business logic, which is considered to be a good practice to put your data-specific business logic into the models. But we can also add utility methods. And we can also overwrite some built-in already existing methods. And a very trivial yet useful method, which we can overwrite here, is the stir method with double underscores in front of it and after it. Now, that's a method which exists on basically every class in Python. It's not Django specific and not model specific. But when you override it, you can define how instances of the class should, for example, be output in the console, in the terminal. For that, you need to return a string in there, and you can now format that string however you want. So here I'll use a f string, a formatted string. And there I then first of all want to output the book name. And then thereafter, maybe in parentheses, I want to output the rating. And therefore here we can simply point at self.title. That's how you add methods in Python classes. You get that self parameter automatically, and then you use it to refer back to the values in instance fields. And here I output self.rating. And with that, I'm saying, hey, whenever a book is output to the console, or in any other place where a string is needed, that's how it should be converted to a string. With that, if I quit that shell, and then restart it, and then again, import from book outlet models. So from there, we import book, and that should be models. And now, again, we can use book objects all, and now we have that more readable output. I didn't have to create the books and save them to the database first, because it's now a database which we're working with. It's persistent data. So when I save something there, that data in the database survives, even if I then close the terminal, stop my server, restart my computer. It doesn't matter. The data is still there. That's why here we don't have to save the data first, but instead we can directly query it again. Now here, I changed something in my class, but I didn't have to run migrations again because I just added a method. I didn't change the structure of a book. I didn't change the fields. But of course, we can do that as well. For example, here for the integer field. For our rating, we might want to set certain boundaries so that, for example, we can't add a rating higher than 5 or lower than 1. And for that, we can go back to the official docs, of course. And there, we learn that on the field options for those models, we can add validators. And then we can have a look at the validators documentation to learn about the built-in validators, which we can use to validate data before something is saved to the database. We can also build our own validators, as you see here. A validator in the end is just a function that takes a value and then either raises an error or not, if it accepts the value. But there also are built-in validators. And for example, there is a min and a max value validator, which is built in. And we can simply utilize that. For that, first of all, in the models file, from Django core validators, we import the min value and the max value validator classes. And then for the rating integer field, we simply set the validators field option and set this to a list of all the validators that should be executed and applied before something is saved in that field. And here we can then add the min value validator and instantiate that and pass the min value we want to enforce as an argument to this constructor, in this case 1. And then as a second item in that list, which we pass to validators, I can add a max value validator and set this to 5. And now I reformat this to make this a bit easier to read. And now we changed this field a little bit and we added our validators. We can also change more. We can, for example, add an author field and set this to models char field max length 100. So that here the author name should be entered and it shouldn't be longer than 100 characters. We can add another field and, for example, add the is best selling book and set this to models Boolean field, because it's a true or false value and we just want to know, is it best selling or not? And if we save all of that, we now updated our book class, but, and that's important, we didn't update the database yet. For the method which we added, there was nothing to update, but once we work on our schema and we edit our existing fields or add new fields, we of course want to tell Django that it should reach out to the database and also update that database, update the table in there, add the new columns. So to do that, what we need to do is quit this interactive shell down there with Ctrl-D, and then simply run python free manage py, make migrations again. Hit enter, and now here I actually get a prompt where I have to pick a choice. Because I'm trying to add a non-nullable field author to book without a default. So in the end, the problem which I have here is that of course we already have some data in our database and we have an existing books table, which up to this point, before we run these migrations, only has a title and a rating. Now I'm about to add 2 new fields, but I already have records, I already have rows in my table for the 2 books we added earlier. So now Django is basically asking me, what do you want to do for those new columns which you're adding? Because by default they're not allowed to be empty, that's what non-nullable means, but I don't know what to do. So what should I do? So we have to select a fix. We can either provide a one-off default now, which basically means that for the existing books we have in the table, some default value, which we specify now, will be set. Or we stop creating those migrations and we go back to our book model class and we tweak the settings for those fields to set up default values there, for example, or to allow those fields to be null. And I'll do the second. So I'll pick option 2 by entering 2, and that quits the migration process. So now I go back to my model here, to my class, and I now want to tweak these two new fields. And we now can either set up a default value by adding the default keyword argument, or we set null to true, which basically means that for this column, an entry in this database can have a null value and will receive a null value if no other value was provided. Null is a special SQL database value type, you could say, and instead of leaving that table blank then, which would simply not be allowed here per our setup, it would get a value which is null. So not empty, but null, which is a special value type representing nothing. Now, setting null equals to true on char fields is not optimal, or at least you might want to reconsider it, because you then have this null type representing no value, and you possibly could also have an empty string, which probably means the same, but we're still going to do it here. An alternative would be to add blank equals true here to allow this field to be empty. So then null equals true wouldn't be required, because if this column does allow blank values, which it would do with blank equal true, everything would be fine. But here I'll go for null equals true instead to insert this null special value if no other value is provided. We're going to see blank in action later in the course as well. And I'll set null to true for the author, but for is best-selling, I'll not do that. We could set null to false, but that's the default. Instead here, I will now simply add a default value here, which is false. So that by default, a book is not best-selling, let's say. With that, with those changes made, we can now run make migrations again. And now you see it succeeded, and it created a new migration file, which now contains the operations Django should execute to update our database. And you see that, for example, here it now simply adds fields for author and is best-selling, and that it manipulates, it alters the rating field to add those new validators which we added. That's what it's about to do. It also has a dependency on the previous migration, and that's only important because you could also roll back migrations, and therefore Django always needs to know in which order they were executed and so on. So with that, we can now run this migration by executing python 3 manage py migrate. And now it reaches out to the database and updates our database data. So let's now have a quick look at that updated data. For that, I'll again enter this interactive shell. And then in there, we import our book class. So from book outlet.models, I import book. And now we can run book objects all to get all the books. And then maybe use index 1 to get the second book, Lord of the Rings. And there, actually, we can now use the dot notation to access the author. That's one of the fields we have now. And that's something we haven't seen before, but you can access all those fields simply with the dot notation on the queried data when you have a single item. That's why I'm selecting a single item with that index here. So here I can access author, but this is empty because I allowed this to be empty, and for the existing records, we didn't add an author. But I can also access is best-selling, for example, and that would be false, because that was our default value here, which we set here. And of course, I can also access the rating instead if I want to, and I would see the rating which I assigned to that book. So that's what I can do here, and that's how we can update our models and then also run new migrations. With that, let's see how we can now also update data in the database. So not update the database and the tables, but the concrete data stored in there. Now I want to briefly come back to this blank versus null thing, and I prepared a little slide here to explain it a bit better, what it's all about. Blank equals true can be set on any model field to control whether that field can be left empty when entering a value in a form, for example. And that's really important. Here we are talking about entering data, providing data for the model for a specific field. Now, null equals true is related but not the same. If a field in a model does not receive any value, because blank is set to true and it therefore may be left empty, then the database, or Django, has to do something with that field when that data is written into the database. Now, for char fields, or any kind of text content, typically an empty string is stored in the database. So there is a value stored in the database, it's just an empty string. For other kinds of fields, like date fields or numbers, storing an empty string is not an option because that would be the wrong data type. For these situations, there is a special null value in the SQL world. This is a special value which can be stored in a database, in a record, in a field of a record, and this can be used for this case. This can be used if a field potentially has no value, but by default, Django does not allow null values. That's why you have to explicitly set null equal to true to tell Django that a given field for a model might not receive a value because of blank equal true, and that in such a case, this null value should be stored and allowed, so that this null value, this special value, is stored in the database. Without null equal true, this would not be allowed, and then for any other fields than char fields or email fields, so for any non-text fields, Django would not know what to store, and it would therefore throw an error. That hopefully clarifies a little bit what blank and null are about, and therefore that is what you should keep in mind when you see those values being used throughout the discourse. So let's now update the data in the database. We got two entries, Harry Potter and Lord of the Rings, but both entries are missing an author and the is best-selling value. They do have false as a default, but clearly that's not correct for these two concrete books. So how can we update data now? Well, the first step is that we need to get hold of the individual books. And therefore, I'll recreate my Harry Potter variable and assign a value which is book.objects.all. I still have book imported and so on. I just scrolled up a bit. And then I'll access the first entry here in that list of entries which we get back. Now we'll find a different way of identifying and getting single records later. For the moment, I'll do it here by position in the entry set. Of course, that's not optimal because we then always have to memorize which book was where. But for the two books here, that's good enough for now. So that's how I can get hold of that first book of all the books we have in the database and store it in a Harry Potter variable. And just to quickly verify that we have the correct book stored there, I'll output the title. So now I can do the same here for Lord of the Rings. Simply get access to book objects all, and then here for index 1, so the second book, and quickly output the title here as well to verify it. And now we got that. So that's good. Now we have this data here with which we can work. Now let's see how we can update the data. And again, updating thankfully is very simple with Django. All we have to do is work with the data as we're used to. So Harry Potter is a regular Python object based on data from a database, but when we work with it, it's a regular Python object, and therefore we can use the dot notation to access its attributes, its fields, like I'm doing it here for the title. But we can not just use that to read values from there, but also to set and update values. And for example, I can set the author to J.K. Rowling here for Harry Potter. So to a string J.K. Rowling. Now if I hit enter, this won't do anything to the database yet. The database will not have changed yet. Just this Python object in memory, not the database. So therefore I can continue and also set is best selling here to true, so to the Boolean true value, because clearly Harry Potter is a bestseller. Now again, nothing was written to the database at this point. To hit the database and update the data there, we now again need to access our variable, so our object here, and then we can call the save method. Now we did call save earlier already, and there we then inserted a new piece of data in the database. Now Django is smart. When you call save on an object that already exists in the database, it will not create a new entry, but instead update the existing entry. So save can do both. It can create a new data entry if you're calling it on some object which has not been saved to the database before. But if you're calling it on an object which already exists in the database as well, it will go ahead and reach out to the database and update the data in there. And that's what's happening here. So I saved this, and now the data was saved in the database. To verify that this is the case, we can again reach out to book objects all and access the first entry in there, which is that Harry Potter book, and output author. And you see JK Rowling, which proves that it was updated because this is now data coming directly from the database. This is now not the Harry Potter variable, but really the result from querying the database. So that's how we can update data. And therefore we can do the same for Lord of the Rings. And definitely also try this on your own here. Pause the video, try it on your own, and set the author and is best-selling flag for this data object in the database. Were you successful? It's basically just the steps you see up there. Now just for the laughter object. I set my author field here to J.R.R. Tolkien. And then I'll set the is best-selling field, of course, to true here as well. And then I'll just call save, like this. And thereafter, we can again also reach out to book objects all, get the second book, which is Lord of the Rings, and output the author to verify it. If we want to, we can also output is best selling, and we see that there our data was saved. So that's how we can save data in a database through Django's model feature. And as you see, it's really straightforward and very convenient. So last but not least, let's also have a look at deleting before we then come back to getting data, getting single pieces of data, and also at setting filters. But first of all, delete. So how can we delete data? Let's say we want to delete Harry Potter. Well, to delete data, what we can do is we can again query our database to get the entry we want to delete. So set Harry Potter equal to book objects all, and then in this case the first book. And then on that Python object, which represents that piece of data in the database, we can call delete. And this will do what the name implies. Now we called save before to insert or update the data. We call delete on the data object to delete the related entry in the database. And then you get back some response from Django where it actually tells you how many items were deleted and for which model those deletions were. And here you see one item was deleted in total, and that was this one deletion for the book model. And indeed, if I now reach out to book objects all, you see only Lord of the Rings is left. So this is how you can delete items with Django and its models feature. Up to this point, if I wanted to get a single book, I always used objects all and then an index to get a single book. Now, this works, of course, though we can also fail if we try to get a book which does not exist for a given index, but it's of course not ideal. We always have to memorize which position a book has, and that's typically not what we want to do. So therefore, instead, it would be nicer if we could simply get a single book by telling Django for which field to filter, or if we could get a list of books that fulfill a certain condition. And therefore, that's what we're going to do. But first of all, for this, we need to add more data. And hence, I want to create more books. And one way to quickly create an entry, if you want to, is to access book.objects_create. There, we can then add the key value pairs we want to have for that book. And that's basically the same as if we would instantiate book and set the key value pairs there, and then call save on the instantiated object. We can do that as well to create a new book, but to skip that extra step of creating an object instance first, on which we call save, we can use book.objects.create instead. And that will simply instantly, immediately hit the database once executed, and it doesn't create a Python object first. So I'll do that to mass create some data, and I'll again add Harry Potter 1. I'll skip the Philosopher's Stone part here, set the rating to 5 and author to J.K. Rowling, and set is best selling here to true. And if I now hit enter, this adds this piece of data to the database, as we can quickly verify by getting all books. Now I'll repeat that and also create a book with the create method, which I'll name My Story, where the rating is 2, the author is Max, so me, and is best selling. I doubt it is, so I'll set this to false. And then I'll add a last 4th book here with create, and that's some random book with a rating of 1, let's say, where the author is random dude or gal, whatever you want, and set is best selling to false as well. So now with that, if we quickly run book objects all, we see that now we have 4 books in there: Lord of the Rings, Harry Potter, My Story, and some random book. And now that we get that, let's dive deeper into how we can query that data, how we can filter it, how we can get single records with these, and so on. To get a single book, we don't have to use book objects all and then a certain index. Instead, we can use book objects get. And this gets us one single data entry if it finds one. Now we therefore need to pass in some criteria, some condition to get a key value pair for the attributes we set up here that identifies the book. For example, we could use ID free. ID is a field we haven't set here, but it is added automatically, as I explained earlier, and it's an auto-incrementing number. So if I run this, we see that it looks like Harry Potter 1 currently has ID free. ID 2 would be Lord of the Rings. ID 1 doesn't exist anymore because that was Harry Potter before I deleted it. Those IDs are then not reassigned. ID 1 is forever gone. So we can use the ID, but we can also use another field, like for example title, and then we can look for My Story, which was my book. And you see I successfully got it. We can, of course, also, for example, get a book where the rating is 5 and I get Harry Potter. Though it is worth pointing out that get will always just get exactly one data entry, even if your criteria here would match multiple entries. Now, for us here, that's not the case. If I have a look at all, we see that all the field values we have are unique, but for example, for is best selling, that would not be the case. So if I get a book here where is best selling is true, I actually get an error because it actually would have found multiple objects that fulfill this condition here. So that's something to be aware of. When you use get to get a single value, you should really use some condition that really only matches one field. And of course, the ID is a perfect condition, therefore, using the ID, because that is guaranteed to be unique. If you use some other value like the title, you should know that it is unique if you want to avoid errors like this. But that's then a more convenient way of getting a single data entry. It's simply a way where you don't have to memorize the position of that entry in the database. But of course, sometimes you don't know if there is just one entry. Instead, you want to get all entries that fulfill a certain condition. And that's something you can also do. With book objects, filter. Filter is basically like get. It also wants named parameters that identify entries by their attribute names here. But filter, unlike get, can return multiple results. So if I, for example, filter by is best-selling true here, I get a query set, a list of all the items where is best-selling is true, which in this case is Lord of the Rings and Harry Potter. If I filter for false, I get those results. We can also filter for multiple things. I can filter for is best-selling false and rating equal to 2. And now I only get my story, because for some random book the rating was 1. So filter, therefore, is very useful when it comes to retrieving a list of values. Now, of course, you don't always want to filter for equality, though. Maybe you want to get all books where the rating is lower than 3. Now, for that, you can't say rating smaller 3. This might seem like it should work, but it won't, because this is invalid Python syntax. Don't forget, you're still writing Python code, and what we're doing here between those parentheses is we're passing in values for parameters, and this is an invalid parameter assignment. Instead, to do something like this, Django gives us special names we can use, special parameter names. Besides checking for equality with the attribute names themselves, you can always append certain modifiers to those attribute names with underscore underscore, and then, for example, LT for lower than, or LTE for lower than or equal. And then you assign the value with an equal sign for which it should be lower than or equal. And the same for just lower than. You use an equal sign to now say, I want to filter for all the books where the rating is lower than 3. And if we hit enter, we get these 2 books which fulfill the criteria. And if you wonder how you should know all those modifiers, of course the official docs help with that. If you search for Django filter, you should find this Making Queries article. And there you can learn all about that in great depth. Of course, I'll cover the majority in this course here. But there you then also will find those field lookups, as they're called. There you are then forwarded to the field lookup reference. And in there, you now get all those lookups which you can add after the double underscores after the attribute name. To, for example, search for things like greater than or equal, lower than or equal, and so on. So that's where you can learn more about that and where you can find a complete list of all the supported modifiers, as I like to call them. Of course, we're also going to see a couple of them throughout this course. You can, of course, also have multiple fields like this. We can search for books where the rating is lower than 3, but where then, for example, the title contains something, which we can do with contains, with the contains modifier. And we could say the title should contain story, and therefore only my story is found. One important word about contains, though, by default, it's case sensitive. That means if we would look for story with a lowercase s, it would not find my story, except for that here it does. The reason for that can be found in the official Django docs. If you're using SQLite, which we are, there is no case sensitivity check. So there contains doesn't care about the casing, and hence it does work like I-contains, which otherwise would be your alternative modifier if you're working with a database where the case matters with contains. Then you could use I-contains to tell the database that your casing should not matter, so that even when searching with a lowercase s, it should find my story. For SQLite, this does not matter. You don't need to use I-contains there. You can, but you don't have to, because contains by default ignores casing, but that's specific to SQLite. Overall, this is how you can use filter and get to find whatever you're searching for. To find specific items with certain conditions, you can add one condition or more conditions, and you can mix and match this how you want. Now, I still want to dig a bit deeper into filter and querying though, because there is more we should be aware of here. Now, the first thing I want to dive in is another type of condition we could be interested in. Up to this point, all those conditions simply were combined with an AND. So we looked for books with a rating lower than 3 and a title that contains story. But what if we want to have either of the two? What if we want to find all books that either have a rating lower than 3 or a title that contains story? Or maybe we want to find all books with a rating lower than 3 or that are best-selling. Currently, we have no way of expressing such a or, but it turns out that Django also has got us covered for that. For this, we just have to import something else. We have to import from Django db.models the Q class. That's a special class Django exposes to us, and this allows us to write queries, that's what Q probably stands for, that also contain an or and not just and combinations. Hence, you also don't need it if you don't need an or. But with that, we can, for example, search with objects filter for rating lower than 3 or is best-selling by simply wrapping our condition in the Q constructor now. So we instantiate Q, and now to that constructor which we call here, we pass rating lt3, and then we don't add a comma, but instead the pipe symbol to add our or condition, which is best-selling equals true. And that basically tells Django that we want to find all items, all data entries where the rating is smaller than 3 or is best-selling is true. And that only works if we use that Q class here. And I have an extra parentheses here which I don't need, so let me remove that, and now it works. And you see I get back a query set which basically contains all books here, because for this condition that indeed makes sense. This condition matches all books. Now we can also combine this with an AND again, simply by adding a comma and then Q, and then simply, for example, check if the author is J.K. Rowling. And if I hit enter, I only find Harry Potter, therefore. So for a or, we combine our Q checks with a pipe symbol. For a and, we use a comma. We then also can omit Q here for the and condition if we wanted to. So here I can get rid of this Q call, not for the or conditions, but I can get rid of it here, and it would still work. There's just one thing you have to be aware of, and that is that if you use and conditions combined with some or Q conditions like here, and you're not using Q for your and condition, you're not wrapping this condition with Q, then this has to come after all your Q conditions, so to say. So this keyword argument has to come after executing your Q conditions. Put in other words, it would not work if I try to move this in front of my Q condition. Here, if I check for author equals J.K. Rowling, comma, and then my Q checks, this would fail, as you see. And that's just something to be aware of. You'll get that error anyways if you try it. I just wanted to show it to you so that you know why you might be getting this. But with that, you can build queries with and or. And with that, we're almost done with the queries. Now I just want to have a last look at them for now, and I want to talk about performance. We saw a lot of ways of querying here, but now I briefly also want to talk about performance, because performance always matters. When you run queries, you learned that certain operations instantly hit the database, whilst others don't. For example, if I create a book and I set a title and so on, then this does not instantly hit the database. That only happens once I call save. Now for queries, it's actually kind of similar. If I add a bestsellers variable, and in there I want to store the result of book, objects filter is best selling true. If I hit enter, you might think that the database is hit by Django and that query is executed. But it actually isn't. Instead, the only thing Django or Python stores in bestsellers up to this point is this query definition, you could say. This query set, but not the result of that query. So the database actually wasn't touched yet. And that matters because you can actually also chain filter calls. So for example, here I'm storing the bestsellers query set, not the result, just the query definition. But maybe I'm also then interested in the amazing bestsellers. And that could be the bestsellers, which I then filter even more to search for a rating greater than 4. So only books with a rating of 5 would match that. That's something we can do because calling filter returns a query set, which itself is an object on which we can again call filter to narrow it down even more. And you can do that how often you want. So now I have 2 query sets, bestsellers and amazing bestsellers, but nonetheless, the database wasn't touched yet, which is good for performance, of course. Django will only reach out to the database and do something with it once you do something with your query sets. So for example, if I print bestsellers, now once I hit enter, Django will go to the database and run the query, because now we really need the data. And the same if I run amazing bestsellers. Though there, for amazing bestsellers, Django is even able to do this in a very elegant way. It notices that amazing bestsellers is based on bestsellers, and it actually caches the results of your query sets, so of running your queries. So when we ran this query, which actually happened when we printed bestsellers, Django did not just reach out to the database and get the data, but it also cached the results. So that, for example, if I run print bestsellers again, it does not go to the database again, but it reuses those cached results. And it does cache them until you change something in the database, for example. But that caching even helps us with amazing bestsellers, because there Django sees that this is based on some cached query set, where we already got the results from before, and hence it will just have a look at that cache result and narrow that down even more. So all these lines up to here, all these lines of code, actually only resulted in 1 database hit. Not 4, not 2, not 3, but 1. And that happened here. And thereafter, we worked with the cached result. And that, of course, is a very nice feature, and it also has an implication for you as a developer. If you find yourself writing some code where you need the results from different query sets, you might want to structure your code such that you allow Django to reuse cached results. For example, code where this would not be possible would be this code. If I run print book objects filter rating greater than 3, let's say. If I run this and I run it again, then we have 2 database hits. Because this is not stored in some variable, hence Django also doesn't cache it. Instead, it re-executes that query against the database every time we run this line. If we, on the other hand, do store that in a variable, so if we do store book objects filter rating greater than 3 in there, then if we print good books twice, the database was only hit once. Because we have this variable which stores the query set, and hence we're using one and the same query set for both prints. Whereas up there, we created 2 query sets, which had the same content, but that's a check Django doesn't perform. Instead, it just sees 2 query sets with no relation, hence it runs 2 operations against the database. Now, that's a little bit more advanced. I still wanted to put it out there because these are things you also should be aware of when working with Django. Because of course you want to write code that is not just easy to read and fulfills its purpose, but that also delivers a good performance. And that is one important aspect you therefore should be aware of when you're working with data and a database. So now we played around with our model here in this interactive shell. And that's nice for learning how to work with it, how to create data entries, how to query them. But of course, it's not ultimately how we're going to work with the model. Instead, I'll quit this interactive shell and close this terminal for now, because we're not going to work in a shell with it. Instead, I want to use that model in my views. I want to have templates where I output the books, for example, and so on. Now, of course, we also might need more than one model in our application, in our website. And we're also going to see more than one model later in the course. We're going to see more than one model in our blog course project. And we're also going to talk about relations between models. But for the moment, I want to keep it simple and focus on this basic model which we have here and how we could utilize that in our views and in our templates. And therefore, I want to create one simple template now where I output all my books. And I then want to make every book clickable so that we're taken to the detail page of the book where we output more information, more details about that book. Just so that we also see how we can use our model in our actual application code, in the views and in the templates. So therefore, I'll start by adding a templates folder in the book outlet folder. So in that app folder here. And in templates, I'll then add an index.html file, which will then be used for outputting a list of all books. And I'll add a book detail HTML file for the single book detail page. I will also add a base HTML file here. And we could add this in a global templates folder as we did it earlier in the course. But to keep things simple and so that we don't have to tweak the settings and add our template dir, I'll just add it in here. Now in base HTML, I'll start by creating that HTML5 skeleton, where I then register a block named title here and end that block, of course, also like this. And here we then add a block named content or body or whatever you want. And we end that block here. So that will be the base template, which I then want to extend in the other two templates. And I'll start with index.html. There, the goal is to extend the base HTML file. And we can insert it like this. Django will find it, but actually, we should, of course, follow that best practice and add a subfolder in templates, which we also name book outlet, and then copy our HTML files into that. So drag them into that book outlet subfolder. And then in index.html, therefore extend book outlet / base HTML. And that's in line with what you learned earlier in the course regarding how to place your templates there and why we have that nested folder in the templates folder. And then here we can add a block title to inject content into that title block in the base template. And for example, here say all books. And then prepare the body. So the block content where we will then render a list of all books. So here we'll then have an unordered list somehow. And in there, I then want to have list items with the books. So for the moment, I'll hard code this single list item here, but soon we're going to output data here, which is coming from a database. But speaking of that, the goal now is to create a view and a URL that loads that view that then renders this HTML page. And therefore, let's go to the views.py file in the book outlet folder. And in there, I'll add a new definition and name this index. And here we get that request automatically, as you learned. And I want to return the result of calling render for that index.html template. So here it's index.html but the first argument is actually the request which we have to forward, and then we render the index.html file for this view function. And to make sure that this view function is called, we want to add a URLs py file here in the app folder, and in there add the URL patterns list. And of course, also make sure that from Django URLs, we import path like this, and then call path here and have an empty path, and also import from dot our views file. So from the current folder, import the views file and load views.index for an empty path here. And we're soon going to add a second path as well, but for the moment, that's it. And in the project URLs py file, in the project named folder here, we therefore, of course, want to import include from Django URLs and then register a new path here, which maybe starts with an empty segment, so that directly after the domain / anything redirects us to the URLs, which I'll include here, and that are the book_outlet.urls. So the URLs defined for that app. And that's all just something you already saw. With that, we can open up this terminal here, this integrated terminal, and then simply run python 3 manage py run server to bring up that development server again, which hosts this Django application. And on localhost 8000, I then get an error, template does not exist. That makes a lot of sense because in views py, that of course should be book outlet / index.html. And with that, if we now reload, here is my book list with this one single item I have at the moment. Now I have no styles here because I want to focus on just the data and the HTML code. Of course, you can add CSS styling if you want to, but I now instead want to focus on how we can actually get the data from the database in our view and pass it on to the template. So how can we now get our book data here? Well, the great thing is it works just as shown in that shell. So from .models, we can import the book. That's how we can import that book class from the models file in the local folder. And that's a standard Python import syntax, of course. And now with the book class imported, you learned that you can query for data by using that book class and then the object's key on that, and then there the filter method, for example. Now you see, my IDE gives me a lot of methods we can use here, and there are a couple of methods we'll also take a look at later in the course, but for the moment it indeed is filter, which I'm interested in. And to filter, I now want to pass my filter criteria, my condition, and actually here I want to get all books, right? So there is nothing to filter. So therefore, let's maybe just use all instead to get all the books. And then here I'll store that in a books variable. This name is up to you, of course. And to expose it to the template, we add our context as we always did. Give this a name of books, for example. So add a key named books, for example, and point at the books we got in this variable. And that exposes those books which we fetched from the database, this list of books, to the template through that books variable, which we'll have in the template. So we can then go to the template and now output those list items dynamically with the for tag. So that for book in books, because that's the key name I assigned in my context, I output my list items. And then of course we also have end for thereafter. And in here, we now can interpolate book.title, for example. So here we can access those attributes which are defined in the model. There I defined title, rating, author, and is best-selling. So these attributes can now be accessed through the dot notation. And here, for example, I could then also say rating in parentheses and then interpolate book.rating. Like this. And if we now save all of that, if we reload, you see the list of books here. And that's how you can query and use the data. And it's the same syntax, the same commands you saw in the interactive shell, which is why I showed them to you there. So what I showed you there can be used just like that in your views or anywhere in your Python code to interact with your data and therefore indirectly with the database. We now render this list of books. Now the goal is to make those books clickable so that we're taken to their detail page, where we then also output the author and the best-selling status, let's say. So to do that, we of course want to work on that detail page and then wire that up. So first of all, in book detail, of course, we extend the book outlet base HTML template. And we then set the title, so with block title, like this, and set this title here then, for example, to the title of the book. That's something we could do on that detail page. So therefore here we can use interpolation and either expect a book variable where we can access title, or we expect that we just get the title like this. And I'll do the latter, but both works. It just depends on which context you then set in your view. Now, of course, we also want to set our content block here, like this. And in there, I want to have a h1 tag, let's say, where I output that title as well. So where I just repeat this interpolation. And below that, maybe an h2 tag where I have the author. So I expect to have an author variable available. Therefore, this also needs to be set by the context when we render the template. And then below that, we maybe have a paragraph where we say the book has a rating of, and then we output the rating, which we expect as a variable. And then I want to say, and is a bestseller, or but isn't a bestseller. So here I want to output content conditionally. I want to have the if tag here and check if is bestseller, if that's true. Else, I want to output something else. And then, of course, we want to end if, like this. So if it is a bestseller, I want to say the book has a rating of rating and is a bestseller. Otherwise, in the else block, and say, but isn't a bestseller, like this. And remove that blank line here. And let's see what this gives us. So that's now my template. Of course, we need a view. So here we can add the book detail view where we get the request and where we then also get some identifier for the book. For example, the ID of the book, because we'll need that to then load that book. And then here we, of course, all return render and forward that request. And of course, also specify the template that should be rendered with book outlet, book detail HTML. And then we want to set a context where we now have to provide all those variables we're accessing here in the template as keys in the context. So we need to set a title key. We need to set a author key. We also need to set a rating key here. And I also want to set the is bestseller key. But of course, the values are still missing here because those values now need to be fetched from the database. Now, assuming that we do get an ID here, we can, of course, simply get our book by reaching out to book, objects, get, and then simply get the book where the ID is equal to the ID we're getting here. And actually, you can even use PK here for primary key. That's a special named argument which you can always use to query the field which is set up as a primary key. And it turns out that in our case, it's that ID field which is configured as such. We see that in our initial migration, that ID is set as the primary key. And for the field where this is the case, which by default is always that ID field, then you can also use PK instead of ID. That's up to you. So I'll go for PK here, and then query the single book where the primary key is equal to the ID we're getting as a parameter. That's then my book. And then here, the value for title is book.title. The value for author is book.author. For rating, it's book.rating. And for its bestseller, it's book.isbestseller. So I'm pulling out that data from that data model, from that data entry we're fetching from the database, and I'm assigning those values to those keys in that context dictionary. So that's all set up. One thing is missing, of course, and that's the URLs. In my URLs PY file in the app folder, I want to add a second path, and that path should include the concrete IDs of the book which has to be loaded, because we're expecting the ID as a parameter. So therefore, we need such a dynamic path segment. We need those angle brackets, and there I want to get the ID. And this has to be named ID here, because I named the parameter here ID. You can use a different name, but then you have to change it here, obviously, and also here. And therefore, I'll stick to ID now. We can also make it clear that this should be a number, an integer to be precise, because that indeed is what our ID is. It should be transformed to an integer because it is an integer. This auto field here, this automatically incrementing ID, by default is an integer. So therefore, we should also transform the ID which we get in the URL to an integer. And then we want to load views.bookDetail, like this. With all of that, if we save everything, if we enter localhost 8000/2, I get an error that book has no attribute is bestseller, because it is best selling in my model, so that's my bad. I am using is bestseller in the template, and that is okay, because that's just a key in the context we're setting up when this template gets rendered. So we can keep this key, but I have to access book.isbestselling here, not isbestseller, because the key in the model is named isbestselling. So that's a fix I have to make. With that, if I now reload, /2, I see the Lord of the Rings data. /3, I see Harry Potter 1. /4, I see my story. And /5, I see some random book. And /6, I get an error because this does not exist. So of course we might want to handle that, and we might want to try getting this book therefore and catch any errors we might be getting, and in this case raise this HTTP 404 error, so that from Django HTTP I import HTTP 404, and I then raise this HTTP 404 error here, so that a default 404 error page would be rendered if we had one. I didn't add one here, but if we had a default 404 HTML template, then that would be rendered whenever this 404 error is raised. So that's how you could handle this. Reload, and then you would get that default 404 page here. And actually, this is such a common pattern that we can use it, but there also is an alternative. We can also set book equal to get object or 404, and then pass in our object class, our model class, like book. And then, second argument, our query criteria, like PK equals ID in this case. So what we passed to get before. And that will then do the same thing as this block of code. We just need to make sure that this get object or 404 function is imported from Django shortcuts. So you need to add that import at the top. But with it imported, you can call this helper function to get data and store it in a variable, or raise the 404 error if it doesn't exist. So we can also save that, and if I now try to load the book for /6, I also get that 404 page. So that's an alternative to manually trying and handling this. But with that, we now also load this detail page. Let's now work on wiring that up and on creating that link here. Now, to wire up this page to the detail page, we of course have to go to the index.html file and add a link here. Add a link. Maybe just wrap the book name and not the rating, but that's up to you. And then make sure that this link points at the correct page. And for this, of course, you learned that it's best if you assign names to your URLs so that you can let Django construct this URL. Therefore, back in URLs py, I want to give the book detail page a name by assigning the name keyword argument here, by adding this. And then we could name this book detail. But this name is up to you. But I'll go with book detail. In index.html here, we can then of course use the URL tag and point at book-detail. And of course, we then need to provide a value for the dynamic path segment this URL has. We need to provide this ID. And therefore here, I then want to set this by reaching out to book.id here. ID is an attribute we can access because, as mentioned before, this ID field is automatically added by Django. If we now save that and reload, we got those clickable links. But you can actually even replace this with a different solution, with a different approach. In the models py file, I mentioned that you can add methods to add custom logic, and that you can also override some of the built-in methods. And there's one specific method which you can set and override, and that is the getAbsoluteURL method. This method is called automatically by Django in some parts of the application. I'll come back to that later. But you can also call it yourselves to get a URL that should represent and load the data for this specific model. And therefore here you should return a string, which is that URL which leads to the page representing this model. So in our case, which leads to this page. And therefore here, we can now also return this URL, and we can build it by using the name we assigned here, by using this reverse function we learned about earlier in the course. You learned that in a template you have this URL tag, and in Python code you have a reverse function offered by Django which you can use instead. So therefore here in your models py file, you can import from Django URLs and import the reverse function, like this. And then here, return reverse, then the name, in this case book detail, so the name of the URL to which you want to create a path, and then your arguments for that URL. So here we add the args keyword argument, and then have a list of the arguments we need to set for this URL. And in this case, that's of course the ID of the book. So here, since this is inside of the book class, it's simply self.id, pointing at that ID field, which will be set by Django. Now with that method added, we can go back to the template, to the index.html file, and instead of using that URL tag, which we can use, there's nothing wrong with it, but instead of doing that, we can now also interpolate here and simply access book.get_absolute_URL and point at this method here. Don't execute it, don't add parentheses, just point at it. And then Django will basically call it for you and get back that URL which it outputs here. And if we now save that and reload this page, we still have our URLs and they still work, but now with help of that built-in overwritten getAbsoluteURL method in the end, which we're utilizing here. And that's not a must use, but it is something to be aware of, which can be useful and which allows you to define your URL creation logic once and then use that anywhere in your code or in your templates where you need to use it. We learned a lot about models up to this point. We also learned how we can output them in templates. There are two main things left which I want to dive in. For one, I want to override the save method and show you why this might sometimes be useful. And I want to do that to give us nicer URLs here, and you'll see what I mean in just a second. And the other thing is, I want to introduce you to some aggregation methods, so getting counts and averages and so on. But let's start with that overriding part and the nicer URLs. Wouldn't it be nicer, also from a search engine perspective, if we had something like Harry-Potter-1? That's this Slug concept which I introduced when we started working on the blog application. And I'd like to have it here as well. So I think that would be nice to have, but how can we achieve this? How can we kind of convert our ID to this Slug type? Well, we don't necessarily need to replace our ID. Having that separate unique identifier might not be too bad. But I want to add a new Slug field, a new Slug attribute to my book model. And that should be of type models Slugfield. There is a specific field for this Slug value type built into Django. And that field will ensure that whatever gets stored in this Slug attribute has this Slug format, so that it does look like Harry-Potter-1. There is some automatic validation for this kind of string built into the Slug field. But how do we now best use that? I think it would be best if we actually would set this Slug field to a certain value whenever we save a new book, so that it's auto-populated, that we don't need to manually enter a slug here, but that it's automatically populated based on the title. Because the slug should always be the title, just transformed to this Slug version. So if the title is Harry Potter 1, it would be great if the Slug field is automatically populated with Harry-Potter-1 like this. And to achieve this, I will now set the default value here to an empty string actually. I will set null to false, which just means it must not be null. And I now want to make sure that a value other than the default value is set whenever we call save. And to achieve this, there's one simple thing we can do. We can override the built-in save method. That is something we can do. We can override this. If we override it though, we have to make sure that we also call the super save method. So here, after we're done with our custom steps, we should call super.save to make sure that Django's built-in save method is still getting called. And we also should make sure that any extra arguments to save, which might be passed to the save method, are forwarded. We're not working with such extra arguments here, but it would be nice to have that in general. So on the save method here, we should accept the args and keyword arguments. And that's some standard Python syntax, which basically says group all positional and all keyword arguments into a summary parameter named args and a summary parameter named quarks. And then let's forward them by splitting them back up into lists of arguments to the built-in save method. And that's something we have to do to make sure that the built-in save method definitely gets called. But now, besides that, we can do whatever we want. And what I do want to do here, before the built-in save method gets called, so before the data is stored to the database, I want to update the slug field. I want to set the slug field to a new value with self slug. And I want to set it to a value which is based on the title, which definitely has been set when save is called. If not, saving would fail anyways. So now we just need to transform title to a slug. And thankfully, Django has a built-in method for that, a built-in function. From Django utils.text, we can import Slugify. That's another import we can add to import the built-in Slugify helper function. And the Slugify helper function does what the name kind of implies. It transforms a string to a slug. So it transforms some text which might look like this to text which looks like this and fulfills this slug formatting criteria. So therefore here in the save method which we're overriding, we can set the slug field to slugify self.title, taking the title which was set and transforming it to a slug. And then we call supersave to save that data to the database. And by doing that, we ensure that such a slug is added for all our models, for all the data entries we have in the database in the end. Now, of course, for the existing data which we have in the database, that will not happen. There we need to update it manually. But typically, of course, you would define your overall model before you start saving data. Here, it's just different because I'm walking through that step by step. Therefore, here we'll have to update the existing data manually, but newly entered data will have its slug automatically set. Hence, here we can save this and now quit the development server. And now with the dev server stopped, I want to run my migrations. I want to create the migrations and run them. Because we changed the model, we added a new field, and therefore we need to make new migrations and run them. Otherwise, our model is not in sync with the database, and that's not a good thing. Hence, here we can run Python 3 manage py make migrations, and then run Python 3 manage py migrate. And thereafter, we can dive back into the shell with manage py shell. And in there, now import from book outlet.models the book model to now get access to the different models and update their slug field. And once the book is imported, all we need to do in the end is reach out to a specific entry, like Harry Potter, so where the title is like this, and call save on that entry thereafter. And if I do that, the slug should be set, because when we call save, we call our updated overwritten save method, and there we do set the slug before we actually call save and hit the database. So just saving the already existing data again should do the trick. Now let's see whether that works. And therefore, let's again get book objects, get title Harry Potter 1, and access the slug there, and it is Harry Potter 1. So that worked. Hence now, to update the other entries as well, we just need to repeat what we just did and get access to Lord of the Rings and call save there to update this. And now here, if I access the slug, that should also be set. Looking good. And then do the same also for my story and also for some random book. And now all those slugs should have been generated as well. And we could also add a brand new book now, and for that the slug should also be set when we then call save. But I'll not do that here. Instead, now I want to make sure that we use that slug for constructing that URL. And definitely try this on your own first, so that that slug is part of the actual URL which is being used. We're going to do it together in the next lecture. Now to use that slug URL, I'll quit the interactive shell here and bring my development server back up with run server. And then we got a couple of things to do. For one, we'll have to tweak this get absolute URL method, but we also have to change URLs py. We no longer expect to get an ID here, instead we expect a slug here. And we can use the slug transformer here you learned about earlier in the course in front of that. Now I'm using slug as a name here, hence in views py I should accept slug as a name here. And I now want to find my book by slug. So instead of checking the primary key and comparing it to ID, I want to check the slug field. So this is the attribute name in the model. and make sure that the value stored there is equal to the slug I'm getting here as a parameter. So right side of the equal sign is the parameter, left side is the attribute name in the model, which also is slug. So this is an adjustment we need to make here. Now I want to make sure that the correct links are generated for this page. And since there we're using getAbsoluteURL, I have to tweak getAbsoluteURL. And instead of passing in the ID as a value for the dynamic path segment, I now want to pass in self.slug and use the slug. With that, if we save everything and reload localhost 8000, we get those more search engine friendly URLs being generated, and they also work as they should. And this is how we could use such a extra field for identifying data instead of the primary key. How we can then also update that field whenever we save. And hence, this is another important pattern or another interesting aspect about models which you should be aware of, which you might need quite a lot when building your own websites, and therefore I definitely also wanted to cover this here. Now, to conclude this part about the slug field which we added, I want to dive back into configuring those fields. We see a couple of options in action already, like max length, null equals true, and the default value. Now for the slug field, we could use another option here, which could help us with performance. Keep in mind that in views.py, we are basically finding a book by slug. We're using the slug attribute to find a book. Now you can find items, you can find data entries by any field you want. Any field defined in your model can be used to find elements. You can even combine them, as you learned when we learned about filter. But if you have certain fields which you use a lot, like the slug, which we will use every time someone visits the page for a single book, then you can improve the performance of that find operation by making that field a so-called index. And for that, you can add the db index option and set this to true. And this will add a so-called database index for that field. Now, database indexes are a technical detail of databases. SQL and NoSQL databases know this concept, and it basically means that the database will save the values in that column a bit more efficiently, or in a way that makes searching them a bit more efficient. And that's some behind the scenes stuff which you don't need to know. All you need to know is that creating such an index for a field can make searching that field quicker. So if you have a field which gets used a lot for finding data, like in our case slug, which we know to find books, then we might want to consider turning it into an index. The ID field, which we get out of the box, automatically has an index. Otherwise, fields don't have an index. And you might think, why don't we make every field an index if it speeds up the search performance? The problem is that creating an index on its own decreases performance. Because whenever you add a new entry to your database, it needs to be added to the index. And if all your fields are indexes, that adds up. So having a few fields as indexes is no problem, but you definitely shouldn't turn all your fields into indexes. Really just the ones which you use a lot for querying. And that's the case here for slug, so there, setting this as an index makes sense. You could also set this to be your primary key if you don't want to use the ID field for that, but I will use the ID field instead. I will not override it because we already have the ID field for existing data and so on. But you could set your slug as your main primary key if you know that you don't want that extra ID field. So therefore, you could do that, but I'll not do it here. And that's it for now regarding those options and those fields. As explained throughout the module already, you can always dive into the official reference to learn about all available fields and all available options, but you already learned about a couple of key fields and options throughout this section, and you're going to see more fields and options throughout the rest of the course. Therefore, now to finally conclude this long module, but it is an important one. But to finally conclude it, let's talk about aggregation methods, because those can also often be important and useful. Let's say on this index page, we want to show the total number of books which we have and also the average rating. How could we do that? Well, thankfully, Django makes this very easy because it has something which is called aggregation methods. It has built-in methods which you can use on your models to aggregate results. And that's what I'll do here in views.py in the index function. Now I don't just want to pass the books to the template, but also the total number of books, let's say, and also the average rating. These two fields should be added here. And to get them, we can again use queries and special methods offered by Django. We already query for all the books here, and therefore I now can use my books query set. You learned earlier that you don't want to repeat queries unnecessarily for performance, so we don't want to run book objects all again. That would be bad because that would create two query sets and potentially hit the database twice. But instead we can use the existing books query set to then kind of get aggregate data out of it. If we want to get the number of books, for example, there is a count method which we can simply call. And then we have the number of books which we can store in a separate variable and then assign as a value to this context key here. And there also is an aggregation method for the average. If we want to get our average rating here, we can access books and then call the aggregate method, which is a more general method that allows us to run different aggregation methods. And now we just need to import from Django DB models the AVG for average class. And there are other classes as well which you could import. For example, there is max and min if you would want to find the total, the overall maximum for a given column or the minimum. But I want to use average, and then here to aggregate, to books.aggregate, you construct average, you instantiate this average class, and as a value, you now pass the field for which you want to build the average. So in my case, I want to build the average on the rating field, so you simply pass rating to average. And this instructs Django to go ahead, have a look at all the books in that query set, and build the average for the rating field, and then return that average here, and in this case, store it in the average rating variable. And then it's average rating, which I also pass, or which I set as a value for this context key. And now in the template, in index.html, we can of course output that. Below the unordered list, we can have a horizontal line, and then simply say total number of books and interpolate our total number of books. So this key here, that's what I use as a variable. And then we can also add another paragraph where we say average rating and interpolate average rating, so that other context key which we set. And with that, if we save that and reload, that's what we see. Now you see for the average rating, you actually get back a dictionary which has rating underscore underscore average as a key, which then holds the result. And therefore here we should actually access this and access rating underscore underscore average with the dot notation here to get the concrete value. And the reason for that is simply that when calling the aggregate function, the aggregate method as we're doing it here, you could pass in multiple aggregation methods. So besides constructing the average, you could also get the min. And you would get back a dictionary where your different aggregation methods are then grouped by key. So for the average on rating, you have rating underscore average. If you also had like min on rating in there, then you would also have rating underscore underscore min in there, and so on. That's why you get this extra dictionary, because you could have multiple aggregation steps grouped together. Here it's just the average on the rating, hence we'll only have the rating underscore underscore average key in the dictionary. But that's another useful feature which allows you to get extra metadata about your data in the database. Now, last but not least, you also sometimes want to sort. And sorting is also very simple with Django. Whenever you build a query set, like here with all, but the same would be true if you used filter, you can also call order by on the query set. And that does what the name implies. It allows you to order the results in the query set. And it will do the ordering on the database level. So it will query for the ordered data and not get the unordered data and then order in Python, but instead it queries for the ordered data so that Python doesn't need to do the ordering at all. But everything is done behind the scenes. You just need to specify by which column, by which field you want to order. And you can also order by multiple fields if you want to. But here we could say that we want to order by title, by specifying title here like this. And if we now reload, you see Harry Potter is first. By default, it orders in an ascending order. You could also order in a descending order simply by adding a minus in front of the field name. So minus title orders by title in a descending order. So if we save that and reload, now it's ordered like this. And of course, we can also order by rating in a descending order. So with minus rating, we make sure that the highest rating is on top and the lowest rating is at the bottom. And these are various nice functionalities which you can easily add, as you can tell, with help of Django and its models. So this was a long course section. We learned about data and databases and models, and you learned that Django makes it easy for you as a developer to work with data and SQL databases because it has this built-in model feature, where you simply build a class and extend the built-in model, and then you can define the fields, the attributes your data has. You can set up the value types you have. You can configure those values a bit. And then you can create and run those migrations to let Django reach out to the database and create and configure the tables in that database as needed. Now, once those tables have been set up, you can interact with them. And you saw a lot of examples in the interactive shell. You can add new entries, you can update and delete entries, and of course you can also get data. Also, as we're doing it here in the views. We're, for example, getting all our books here, but earlier in the module, you also saw that you can filter and set up conditions to only get the books with a certain rating or anything like that. You can then also order and count or run other aggregation methods as explained in the very last lecture. And once you got your data, you can of course output it in a template as you learned it with tools like the for loop. Now, of course, you cannot just get lists of data. You can also get individual books, for example, with the get method or this shortcut method to throw a 404 error if the book is not found. And you can then also output that individual data as you learned. Now here we're using a slug, which is an extra field we added to the model to have this search engine friendly identifier besides the built-in auto-incrementing ID, which we could have used instead. You can of course use any unique identifier if you want to find a single data entry. Now speaking of the slug, there you also saw that we can override the save method, for example, to make sure that the slug is set whenever values are saved. And you also saw get absolute URL, which makes it easy to build a model-specific URL, which you can then use wherever you need to use it, for example in your templates. Here it's just worth pointing out that despite it being a method, it actually is used as a property. You simply access it with a dot and you don't add parentheses here. Instead, you really just point at it and Python executes it for us, so to say. And that is basically it. Now, there are more things we can take a look at. For example, relations. And we're going to take a look at that throughout the course. But in the next course section, I actually first of all want to dive into a feature called administration. Django has a built-in administration UI and mode, which makes managing data way more convenient than with that shell which we used in this course section. So therefore, that's what we're going to dive in next.